bringing a long-dead species back from extinction by meticulously putting together its whole DNA sequence, or genome, used to be science fiction. It's not nearly as simple as Jurassic Park would have us think, but in the age of DNA editing, the possibility of cloning an ancient creature is no longer a pipe dream. The team at the DNA Zoo has made a step toward cloning one of Australia's most beloved and missed extinct species, the thylacine, or Tasmanian tiger. Welcome to today's episode of AI News. In this episode, I will show what artificial intelligence already accomplished in resurrecting dead species and what it will accomplish very soon and how it might impact society itself. They accomplished it by creating a chromosome-length 3D genomic map of one of the thylacine's closest living cousins, the numbot. Although it previously ranged throughout southern Australia, the striped, termite-eating numbot is Western Australia's faunal symbol, and it currently only inhabits in isolated areas of that state. Importantly, numbots and thylacines shared a common ancestor that lived between 35 and 41 million years ago, which is a very recent evolutionary time period. Both of these mysterious organisms have stripes, but that's not the only thing they have in common. Up to 95% of their DNA may be identical. The intriguing promise of decoding the whole numbot genome raises the enticing prospect of piecing together the genetic sequence of the thylacine, which in turn raises the tantalizing prospect of restoring one of Australia's most iconic vanished species. This will undoubtedly be more difficult than the famous attempt to recreate the woolly mammoth using DNA from an Asian elephant. The thylacine's revival is now more likely than ever thanks to the availability of the numbot genome. Following the Tasmanian devil, quoll, and dunnart, the numbot is the most recent marsupial genome sequence produced by our team at the DNA Zoo. They have collected genomes from over 500 animals from throughout the world, with the goal of making all of them available for conservation and open access study. They're also working on a comprehensive genetic examination of most Australian carnivorous marsupials, which will result in a complete peer-reviewed scientific article. They can now provide a significant resource to other scientists and conservationists investigating numbots and other marsupials by providing the sequence publicly at this level of our research. Time is ticking rapidly for them, given the conservation risks they confront. In 2018, scientists put together the first draft of the Tasmanian tiger genome using century-old museum materials. However, this version is incomplete, and some important gaps must be addressed before this puzzle can be assembled into a whole genome sequence. Unfortunately, there was not enough high-quality DNA in the ancient museum samples to overcome these concerns. So, what do you do if you don't have certain obviously vital ingredients? This is where the genome of the numbot, the thylacine's closest living relative, can aid. Our new high-resolution numbot genome map may be able to assist us in filling in the gaps in the thylacine genome. Between possessing a full thylacine genome and actually cloning a thylacine, there will be substantial challenges. CRISPR gene editing technology, a combination of enzymes that allows scientists to target highly specific pieces of DNA, transforms this scenario from science fiction to a possible reality. CRISPR has been dubbed molecular scissors because it allows for the exact selection and insertion of DNA from specimens, potentially enabling for the de-extinction of the thylacine or other species by allowing geneticists to deliberately fix the missing sections of its genome. Geneticists might hypothetically assemble together a set of chromosomes using these and other synthetic biology technologies, which could then be introduced into an egg cell with its old nucleus removed, allowing the new DNA to operate as the egg's genetic blueprint. This is the method being used by a U.S. research group to clone the mammoth by filling in the missing parts of mammoth DNA with DNA from its closest living cousin, the Asian elephant. Rapid advances in embryology and genetics are opening up the potential of reviving extinct species, or at the very least developing something that is near enough to the original to develop and mature properly, all over the world. Dolly, a sheep cloned by British scientists, was successfully cloned in 1996. The same procedure was then utilized by Chinese researchers in 2017 to make two genetically identical long-tailed macaques. Harvard biologist George Church has created Colossal, a biotech business focused on generating an elephant-mammoth hybrid, with the first calves anticipated in 6 years, thanks to the booming area of synthetic biology and precision genome editing tools like CRISPR. Of course, the numbot is one of Australia's most well-known native marsupials. It, like the Tasmanian tiger, was on the verge of extinction in the late 20th century, but major conservation efforts, as well as government and community participation, are slowly restoring its numbers. Despite the fact that there are less than 1,000 numbots surviving in the wild and the species is still classed as endangered, our genetic blueprint could pave the way for improved numbot conservation data for our frontline biologists. Many of these researchers are working to combat the hereditary illnesses that are threatening the numbot's extinction. So far, the discussion has centered on whether or not we can do this. Now we're at the point where we're thinking, holy crap, we can, so should we? Douglas Macaulay, an ecologist at the University of California, Santa Barbara, who wasn't involved in the research, agrees. It's as though we've just about finished putting the last stitches in Frankenstein's monster. And now we're debating whether it's a good idea to flick the switch and bring the creature to life. However, the findings reveal that putting the money into existing conservation efforts for live species, rather than focusing on de-extinction, will result in a considerably larger gain in biodiversity, roughly 2 to 8 times more species rescued. In other words, the funds would be better spent elsewhere to avoid current species from becoming extinct in the first place, according to a study published today in Nature Ecology and Evolution by the team. There's always the possibility that a wealthy individual or corporation may be enthralled by the allure of extinction and opt to support a project like this. The authors claim that if this money had not gone to conservation efforts of any kind, it would be a tiny victory for the planet's biodiversity. All power to that billionaire if he or she is just interested in bringing a species back from the dead, says first author Joseph Bennett, a biologist at Carleton University in Ottawa. That billionaire, on the other hand, is being deceptive if he frames it as a biodiversity protection effort. There are many species on the edge of extinction that might be spared if the same resources were available. The new research is sobering for Macaulay, who recently released a set of principles for picking de-extinction animals that will do the greatest good for the environment. I'm out if something is unethical, environmentally unsound, and now also prohibitively costly. De-extinction is still a fantastic concept conceptually. Bennett summarizes the paper's conclusions concisely as a conservation tool in a world of tight budgets. It is preferable to spend money on the living rather than the dead. Before the thylacine can be cloned, there is still a long way to go. But, if it works, any de-extinction project would almost certainly result in the reintroduction of creatures into the wild. If that happens, the thylacine already has one advantage over many other prospects for extinction: suitable habitat. There would be plenty of places for thylacines to reside, with reserves encompassing almost half of Tasmania today, still teeming with the prey species they used to devour. It has a good chance of being returned to the Tasmanian wilderness. There's also a solid reason for it. The thylacine was formerly Tasmania's most important carnivore. Returning it to the top of the food chain might aid in the restoration of threatened habitats. So, what is your opinion on scientists gaining the ability to bring back long-dead species? Do you think they'll be able to do that, and if so, which animals would you like to see come back to life? Please tell us your opinion in the comment section below. I would love to hear what you have to say about it. Thank you for watching AI News. We consistently report on the newest technologies that are shaping the future of our world. We'd appreciate you subscribing and watching our other videos. See you around and take care.